Welcome to the Sleepy Brain Facts channel. I'm truly glad you're here. Perhaps you've had a long day, or maybe you find comfort in drifting off to sleep with deep thoughts and cosmic mysteries instead of counting sheep. Whatever the reason, tonight's journey is crafted just for you. Take a moment to relax, let your mind ease, your breathing slow, and your body feel light, as if gravity has softened its grip. Tonight, we won't just be stargazing, we will glide through our home galaxy, the Milky Way. This magnificent spiral of stars, dust, and dark matter has been turning gracefully in space for over 13 billion years. Yet, beneath its stunning exterior lie secrets waiting to be uncovered. We will explore rogue stars, invisible forces, and ancient remnants that challenge our understanding of the universe. Our journey will take us from the spiral arms to the hidden core, revealing colossal collisions and stars that predate the galaxy itself. You'll hear tales of black holes, stellar nurseries, and the intriguing, unfinished story of a galaxy that continues to grow. Some of the wonders you encounter tonight might surprise you, or at the very least, spark your curiosity as you drift off to sleep. And before we embark on this exploration, if these calm and curious narratives help you unwind or provide a peaceful end to your day, please consider liking and subscribing to the channel. Imagine a journey through the cosmos where you find your place among the stars. Let's embark on this adventure together. The Milky Way, our celestial home, has a rich history of collisions and transformations. It may seem stable, but it's woven from the remnants of other galaxies, shaped by their stories. Over the course of billions of years, the Milky Way has absorbed smaller galaxies, drawing them in and scattering their stars into beautiful tidal streams that wrap around its disk. Right now, the Sagittarius dwarf galaxy is being torn apart, a testament to this cosmic dance. Meanwhile, Andromeda drifts slowly closer, and in about 4.5 billion years, these two magnificent spirals will collide in a spectacular event. Although stars rarely collide, the shapes of the galaxies will forever change, merging into a vast, serene new form. Even galaxies are not eternal. They evolve, collide, and begin anew. Some stars in our Milky Way are older than the galaxy itself, having traveled from ancient times. These halo stars, composed of primitive metals, wander through long tilted orbits, hinting at their origins in smaller primordial galaxies that merged with ours long ago. As you contemplate this cosmic tapestry, consider how interconnected everything truly is. Each star, each galaxy, contributes to the grand narrative of the universe. Would you like to continue exploring this fascinating story, or perhaps take a moment to reflect? Their chemical fingerprints reveal a striking absence of heavy elements, indicating they emerged shortly after the Big Bang. Picture them moving slowly, high above the galactic plane, like ancient spirits from a time before spirals and before order took shape. In their light, you glimpse a universe that was younger, wilder, still discovering what it could be. Our solar system orbits the center of the Milky Way at a breathtaking speed of over 828,000 kilometers per hour. That's more than 230 kilometers every second. Yet, it takes about 225 million years to complete just one full revolution around the galaxy. This journey is known as a galactic year. In terms of Earth's timeline, we've circled the Milky Way only about 20 times since our solar system came into existence. When the first dinosaurs roamed the Earth, we found ourselves in a completely different part of the galaxy. The stars we see today weren't always in our vicinity, and they won't always remain there. Everything is in constant motion. Quietly, slowly, and endlessly, the universe continues to evolve. Even as you sleep, the Earth turns beneath you, the Moon orbits, and the entire solar system moves forward through a galaxy that is alive. Though the Milky Way is ancient, it is still growing. It continues to gather material, absorbing gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter that nourish its halo. This cosmic dance is far from over. Isn't it fascinating to think about? You are part of this ever-unfolding story. Imagine a galaxy growing not like a living organism, but more like a gravitational structure, deepening with the passage of time. Sometimes, this growth occurs quietly, as clouds of gas infill the space. Other times, it disrupts the cosmos, tearing apart satellite galaxies and scattering their stars across the vast sky. The Milky Way you inhabit today is not the same one that the dinosaurs witnessed, and who knows what your distant descendants might see. Perhaps a galaxy even larger, formed from the remnants of countless smaller worlds. Isn't it curious that we don't even know how many arms the Milky Way possesses? You might think this is something we should have figured out by now. From our vantage point, deep within the galaxy's disk, it's challenging to grasp the entire structure. Dust clouds obscure our view of distant regions, and stars often blur together. For many years, astronomers believed there were 4 major spiral arms. Yet, recent observations suggest there might be fewer, or that the arms twist and split in ways that are more complex than we initially thought. Some arms fade into fragments, while others wrap around in unexpected patterns. The Milky Way may not be the neat pinwheel we imagine. Instead, it resembles a living, layered swirl of stars, shaped by forces we still struggle to comprehend. While most stars drift calmly through the galaxy, a rare few are flung outward at astonishing speeds, propelled far enough to escape the Milky Way entirely. Take a moment to reflect on this cosmic dance. What mysteries might still lie hidden in the depths of our universe? Imagine hypervelocity stars, remarkable celestial beings that tell a fascinating story. Some of these stars are the remnants of binary systems, torn apart by the supermassive black hole lurking at the heart of our galaxy. One star is drawn in, disappearing into the abyss, while the other is flung outward, racing through the darkness at speeds exceeding 1,000,000 kilometers per hour. These rogue stars journey alone, far from the galactic plane, resembling glowing comets with no path back. They serve as a reminder that within a galaxy governed by gravity, there exist moments of chaotic release, quiet expulsions that cast stars into the vast intergalactic night. As you gaze up, you might notice the Andromeda galaxy hovering high above the horizon. To the naked eye, it appears as a faint blur, a spiral much like our own, lying over 2 million light-years away. Yet, it is steadily advancing toward us. In approximately 4.5 billion years, the Milky Way and Andromeda will collide. This event won't be the cataclysmic clash you might envision. The stars within these galaxies are spaced too far apart to collide directly. Instead, their gravitational forces will stretch both galaxies into graceful arcs. Tidal tails will unfurl, and black holes may spiral together, leading to a slow, elegant merger into a single, larger system over billions of years. This unfolding future of our cosmic home is written across the stars, a beautiful dance of galaxies intertwined. How does this vastness make you feel? Take a moment to reflect on the wonders of the universe. You are part of this grand narrative, and as you dwell on these thoughts, consider what lies ahead. Would you like to continue exploring, or perhaps take a moment to rest? Some stars move in unexpected ways, orbiting backward, while most stars in the Milky Way follow a general path around the galaxy's center. A few defy this norm, particularly in the outer halo, Some stars travel in retrograde, spinning in the opposite direction of the galaxy's primary rotation. These stars likely originated from other places, perhaps born in dwarf galaxies that the Milky Way later absorbed. Their backward motion serves as a subtle reminder of their foreign beginnings, as if the galaxy carries echoes of its past in the graceful dance of its stars. Imagine the Milky Way as a tapestry woven from ancient stories, tales of cosmic mergers and encounters, not told through light, but through the slow, deliberate movements of stars that seem to defy time. Over billions of years, the Milky Way has not simply grown, it has consumed. Small galaxies, like faint companions, have ventured too close, caught in the gravitational embrace of our galaxy, only to be gradually dismantled. The stars from these smaller galaxies now enrich our halo and stellar streams. Astronomers have uncovered the history of these mergers by studying the motions and compositions of stars. One particularly significant event, known as the Guan-Celadus merger, contributed a multitude of stars and may have reshaped the early structure of the Milky Way. This galaxy is not a pristine spiral. It is a rich mosaic, crafted from quiet collisions and stitched together from the remnants of many smaller worlds. As you reflect on this cosmic journey, consider how the universe is a canvas of stories, where every star carries a piece of history. Wouldn't you like to continue exploring these wonders? The chemical composition of stars holds the key to their origins. Each star possesses a distinctive chemical fingerprint, a unique pattern of elements formed at its birth. By examining these signatures, you can trace the history of a star. Some stars are abundant in heavy elements like iron and calcium, indicating they emerged from dense, metal-rich regions. Others consist almost entirely of hydrogen and helium, originating from a time when the universe was still in its infancy. These variations enable scientists to categorize stars into families, revealing ancient mergers and piecing together the hidden narrative of the Milky Way's formation. In this sense, chemistry transforms into a time machine, allowing you to read a star's past like an ancient poem inscribed in light. The night sky is adorned with stellar streams, remnants of galaxies that have been torn apart. Thin ribbons of stars stretch across the heavens in delicate arcs and curves. While they may be faint, their presence becomes unmistakable when mapped with precision. These stellar streams are the remains of smaller galaxies that ventured too close to the Milky Way and were gradually pulled apart. As they orbit, tidal forces stretch their stars across space, creating long, fragile trails that trace their former roots. Some of these streams encircle the galaxy like ethereal halos, while others plunge toward the core. Isn't it fascinating how the cosmos tells its story through these celestial remnants? These streams serve as a reminder of ancient collisions and quiet mergers that have shaped the Milky Way over billions of years. Just like a tree reveals its history through its rings, our galaxy carries the marks of its past in every beam of light. However, the Milky Way is not a perfect spiral. It has a unique warp. Its disk rises on one side and dips on the other, creating a graceful wave across the cosmos. This subtle distortion remained hidden until radio telescopes mapped the hydrogen gas that extends far beyond the visible stars. Astronomers suggest that this warp may be influenced by satellite galaxies gently tugging at the Milky Way's edges, or by clumps of dark matter pulling from below. Imagine ripples on a spinning sheet. The warp illustrates that even galaxies are never entirely still. Over time, they bend, flex, and transform in response to unseen forces. From afar, the Milky Way appears to dance slowly through the vastness of space. Yet, with the naked eye, you can only glimpse about 0.0003% of its entirety. Under a clear, dark sky, far removed from city lights, you might see a few thousand stars. To our eyes, that looks like an ocean of light, but it's merely a drop in the vast sea of the Milky Way, which harbors over 100 billion stars. You find yourself surrounded by a vast universe, much of which remains hidden from your view. Some of it lies behind thick curtains of dust, while other parts are simply too faint or distant for your eyes to perceive. On moonless nights, the pale streak of the Milky Way crosses the sky, offering just a whisper of the enormity that surrounds you. You live amid a colossal river of starlight, yet most of it eludes your grasp, too immense to fully understand from within. Stars orbit the galaxy at varying speeds, unlike planets, which follow neat paths around their sun. In the Milky Way, stars move freely. Some race ahead in the galaxy's inner regions, while others drift slowly along the outskirts. This variation in speed is what gives rise to the spiral arms. These arms are not solid structures. Instead, they resemble patterns, much like slow traffic jams of stars and gas flowing through the cosmos. As these density waves move, they ignite the birth of new stars, illuminating the arms with beautiful curls of blue and white. Your own sun is part of this cosmic dance, weaving in and out of these patterns over time. The galaxy is not a clock, it is a current, and you are drifting along with it. Yet the galaxy remains bound together by something unseen. Logically, the Milky Way should not exist as it does. Based on what we can measure, stars, dust, gas, the outer edges of the galaxy spin too quickly. Isn't it fascinating to ponder what lies beyond our perception? Imagine a cosmos where stars and galaxies are flung into the void, scattered like leaves caught in a storm. Yet they remain anchored, held together by a force we cannot see. This force is dark matter, and this enigmatic substance does not shine, reflect, or emit any light, yet it exerts a gravitational pull so powerful that it outweighs all the visible matter in our galaxy many times over. While we may not fully understand what dark matter is, we recognize its crucial role. Without it, the Milky Way would drift apart, unraveling like a thread pulled from a tapestry. Dark matter serves as the invisible scaffolding that keeps everything in place. At the very heart of our galaxy lies a supermassive black hole known as Sagittarius A. This colossal entity is over 4 million times the mass of our Sun, yet it occupies a space smaller than Mercury's orbit. Although we cannot see Sagittarius A directly, we observe nearby stars racing around it at incredible speeds, tracing invisible paths through the emptiness of space. Occasionally, gas and dust spiral inward, creating brilliant flares of X-rays as they approach the event horizon. For now, Sagittarius A remains in a state of slumber. However, in the distant past, it may have burned brightly like a quasar, illuminating the galaxy from within. It is the silent conductor of the Milky Way's heart, orchestrating a slow, relentless dance of stars drawn into its gravitational embrace. Would you like to explore more about the mysteries of our universe? The Milky Way presents a fascinating peanut-shaped bulge at its center. When astronomers explored this region, they stumbled upon an unexpected revelation. Instead of a smooth, rounded mass of stars, they found a three-dimensional peanut shape. Viewed from the side, it swells in the middle and tapers at the ends, resembling a twisting hourglass crafted from stars. This peculiar structure likely emerged from the galaxy's central bar, a dense alignment of stars that rotates slowly, gradually bending and puffing upward over eons. These intricate inner formations are molded by gravity, shaped through billions of years of motion, and the rhythmic dance of stellar orbits. While we reside in a spiral galaxy, its core is anything but simple. It brims with complexity. Far from flat or tidy, it is intricate and vibrant. The spiral arms of the Milky Way are not just collections of stars, they are intertwined with the very birthplaces of those stars. Enormous clouds of hydrogen, dust, and molecules drift throughout the galaxy. As these clouds traverse the spiral arms, they become compressed and ignite, giving rise to new stars. These areas, known as stellar nurseries, are chaotic, radiant, and teeming with activity. The ultraviolet light emitted by these young stars illuminates the surrounding clouds, painting the arms in brilliant shades of blue and silver. Isn't it remarkable to think about the dynamic beauty that exists within our galaxy? Imagine the bursts of creation tracing a spiral shape, softly illuminating the curves of the galaxy with a gentle glow. Every star, including our sun, originates from these ancient cloudy cradles. Surrounding the Milky Way is a vast halo, a structure beyond the thick spiral disk. This spherical halo envelops the entire galaxy, harboring ancient stars, globular clusters, and immense quantities of dark matter. Although nearly invisible, this halo may actually contain most of the Milky Way's mass. Its stars are spread thinly across vast distances, orbiting in long, slow arcs that seldom intersect with the disk. The halo also holds the remnants of ancient galactic mergers, streams and shells of stars that have been torn from smaller galaxies and left behind like cosmic fossils. It serves as the galaxy's outer memory, quiet and dim, yet always in motion, continually shaping the future of the Milky Way. Within this halo, over 150 globular clusters exist. These clusters are some of the oldest objects in our galaxy, compact spheres composed of hundreds of thousands of tightly bound stars. They orbit the galactic center in the halo, much like moths drawn to a distant flame. Remarkably stable, some of these clusters are more than 12 billion years old, and many contain stars that predate the Milky Way itself. As you reflect on this cosmic tapestry, consider the stories these ancient stars hold and how they continue to influence our understanding of the universe. Imagine a universe where stars shine with a unique story. These stars, known for being metal poor, emerged in a time when the cosmos had yet to forge many heavier elements. They act as time capsules, offering us glimpses into the galaxy's formation, its consumption patterns, and the conditions that prevailed in the universe's early days. Picture these quiet golden spheres drifting serenely above and below the galactic plane, their glow illuminating the darkness. Yet, the cosmos is not without its turbulence. Occasionally, we witness disruption as satellite galaxies are torn apart, scattering their stars across the night sky. These rogue stars wander alone, far from the galactic plane, resembling glowing comets without a destination. Star formation is gradually slowing down. In the past, the Milky Way thrived with activity, birthing new stars from dense, collapsing clouds. However, in recent epochs, this vibrant pace has diminished. While there is still gas available, much of it is now thinly spread, heated, or trapped in forms that resist collapsing into new stars. The galaxy is not finished creating stars, but it is entering a phase of settling. Astronomers believe that the peak of star formation occurred billions of years ago and has been on a decline since then. This doesn't signify an imminent end. Rather, we find ourselves in a quieter chapter of the galaxy's life. The Milky Way, a mature spiral, glows gently in its middle age, still nurturing the birth of stars, but no longer in a rush. Some of these stars even formed before our galaxy developed its disk. As you reflect on this cosmic journey, Consider the stories these stars hold and the mysteries they continue to unveil. Imagine the Milky Way, that broad, flat spiral galaxy we often think about. It forms gradually, shaped by time and cosmic forces. Yet, some stars within this galaxy are older than the very disk they inhabit. These ancient stars are mostly found in the halo, or the thick disk, remnants from an era when the galaxy was still taking shape, a loose collection of stars, gas, and dark matter slowly collapsing inward. As you explore the cosmos, consider how astronomers study the composition and movement of these stars. They allow us to look back into a time before structure, before the spirals, revealing the elders of the galaxy. These magnificent stars stand as silent witnesses to the birth of our universe and the slow unfolding of what we now call home. Now, let's think about time on a grand scale. A galactic year spans approximately 225 to 250 million Earth years. As our sun orbits the center of the Milky Way, it completes one full revolution every few 100 million years. This vast cycle, known as a galactic year, dwarfs our human calendars and reminds us of the slow heartbeat of cosmic time. In the time it takes for the sun to circle the galaxy just once, continents drift, species rise and fall, and entire epochs unfold. Currently, we find ourselves about halfway through one such orbit. The last time our solar system occupied this part of its path, the supercontinent Pangaea had just begun to fragment, and dinosaurs were yet to make their appearance. Take a moment to reflect on this immense timeline. It invites a deeper understanding of our place within the universe, a reminder that we are part of a much larger story. As you absorb this cosmic perspective, consider how it shapes your view of time and existence. Would you like to continue exploring this awe-inspiring journey, or perhaps take a moment to rest and reflect? The Sun has completed fewer than 25 orbits around our galaxy. In its remarkable 4.6 billion years, it has circled the Milky Way just about 20 times. You might find that surprising, especially considering its incredible speed of nearly 830,000 kilometers per hour. Yet, the galaxy is immense, and the Sun's path is so lengthy that each orbit takes hundreds of millions of years. We often perceive stars as ancient and static. However, in the grand scheme of the galaxy, our solar system is still relatively young, a newcomer among older, more seasoned stars. We are part of the galaxy's ongoing motion, but we are still at the beginning of its intricate narrative. The Milky Way's rotation challenges Newton's laws. According to Newtonian physics, stars farther from the galactic center should orbit more slowly, much like how the outer planets move around the Sun. Yet in the Milky Way, stars in the outer regions orbit almost as swiftly as those near the center. This observation contradicts classical expectations. Astronomers believe the explanation lies in dark matter, an invisible and mysterious form of mass that envelops the galaxy in a vast halo. Without dark matter, the galaxy would not remain intact. With it, however, the mathematics align perfectly. The Milky Way turns like a solid wheel, not because we have all the answers, but because something unseen is keeping it all together. As you reflect on this cosmic dance, consider how much there is yet to discover. Wouldn't it be fascinating to delve deeper into the mysteries of our universe? Imagine the galaxy, a vast expanse filled with enormous molecular clouds. Scattered throughout the Milky Way, these dark, cold clouds of gas serve as the essential building blocks for stars. Composed primarily of hydrogen molecules and tiny traces of dust, these clouds can stretch across hundreds of light years. Within their chilly, dense interiors, gravity begins its work, gathering material into clumps that eventually collapse into new stars and planets. Some of these clouds are so immense and frigid that they absorb all visible light, appearing as deep black patches against the starry sky. They are the hidden wombs of the galaxy, quiet and secretive, where the future begins in silence, nestled within layers of shadow and gas. Now consider the supernova, which stir the galaxy like powerful storms. When massive stars reach the end of their life cycles, they explode in spectacular supernova, events so intense that they can outshine entire galaxies, if only for a brief moment. These explosions do not merely signal an end, they give rise to new beginnings. The shock waves from supernova ripple through the interstellar medium, compressing nearby clouds and sparking new waves of star formation. They enrich the surrounding space with heavy elements like iron and gold, forged in the heart of the dying star. In this way, supernova act as vital storms within the galactic ecosystem, stirring, fertilizing, and reshaping everything in their wake. As you reflect on this cosmic dance, consider how the universe continually creates and transforms, reminding us of the beauty and complexity of existence. Would you like to continue exploring, or take a moment to ponder this wondrous cycle? In the galaxy, moments of chaos unfold, destructive, radiant, and undeniably necessary. Dust conceals vast areas where stars are born. The Milky Way is brimming with light that remains invisible to our eyes. Interstellar dust, composed of tiny grains of carbon, silicon, and ice, drifts through the galaxy in intricate clouds and tendrils. To our eyes, it obscures immense stretches of space, hiding stars and entire nebula. Yet, behind this veil, the birth of stars continues. Infrared telescopes have the ability to pierce through the dust, unveiling sparkling nurseries filled with newborn suns. What may appear as darkness often serves as a cradle for new beginnings. This dust, while it conceals, plays a crucial role in the process. It absorbs energy, cools gas, and protects the delicate stages of stellar birth. What seems like emptiness is frequently the start of something brilliant. Across the Milky Way, we discover starless gas clouds drifting silently. Not every cloud of gas transforms into a star. Astronomers have identified large, cold clouds that seem poised for collapse, yet remain dark and dormant. Some clouds are simply too diffuse, while others may be stabilized by magnetic fields or internal turbulence. These starless clouds float through the galaxy, representing silent possibilities. They are rich in molecular hydrogen, untouched by the fire of fusion. Imagine a universe where stars ignite with brilliance or gently drift away, eventually torn apart by the forces around them. Their remnants are recycled, spreading across vast regions. In this cosmic dance, the Milky Way holds its breath, perhaps waiting for just the right moment to spark something new. The Milky Way is a dynamic tapestry, continuously recycling matter through generations. Stars are not eternal. They live, burn brightly, and ultimately meet their end. In their dying moments, they return their materials to the galaxy, enriching it. Supernovae scatter heavy elements, while red giants shed their outer layers. The remnants drift outward, joining the interstellar medium, where they cool and condense, eventually giving birth to new stars, planets, and even life itself. Every atom in your body has traveled this incredible journey. Born in a star, scattered through the cosmos, and reformed into something new. The Milky Way is not merely a static backdrop. It is a magnificent engine of renewal. It breathes in sync with its stars, creating, destroying, and beginning anew. Metal-poor stars hold secrets of the early universe. In astronomical terms, metals refer to any elements heavier than helium, not just iron or gold. The first stars that emerged in the universe lacked these metals, having formed before previous generations had the opportunity to forge and scatter them. Today, astronomers are on a quest to find these metal-poor stars in the halo of the Milky Way, piecing together the story of our cosmic origins. Isn't it fascinating how interconnected we all are? Imagine the stars above you, faint yet ancient, holding the secrets of a time long past. As you explore their composition, you find yourself peering into the primordial past, a moment just after the Big Bang. This was before galaxies matured and before the Milky Way took its full shape. These stars are like fossils made of light, each telling a story of its own. You might wonder about the journeys of these stars. Some wander far from their birthplace, showing that a star's origin doesn't always dictate its future. Over time, many stars drift away from their natal clouds, influenced by gravitational interactions, orbital resonance, or the gentle pull of spiral arms. Some are ejected at high speeds, flung across the galaxy, while others migrate gradually, shifting their orbits as they spiral through the cosmos. Even our sun, shining brightly in the sky, is not where it first began. Tracing the paths of stars reveals a Milky Way that is vibrant and ever-changing. It's a galaxy alive with movement, interactions, and quiet dislocation. The home of a star may be only temporary, reminding us that even in the vastness of space, nothing is truly static. Consider the Milky Way's habitable zone, which may stretch across tens of thousands of light years, just as Earth orbits in a Goldilocks zone around the Sun. Not too hot, not too cold for life. The Milky Way might have its own galactic habitable zone. This area is thought to exist between the dangerous inner core, filled with radiation and gravitational chaos, and the sparse outer edges, where forming planets can be a challenge. As you reflect on these cosmic wonders, allow yourself to feel the connection to the universe. There's so much more to explore, and you are invited to continue this journey or pause to contemplate the beauty of it all. In a vast expanse, there exists a zone where conditions remain stable, star density is moderate, and essential elements like carbon, oxygen, and iron are plentiful. You find Earth nestled within this space, quietly orbiting in a swirling cosmos, where life may not be alone in establishing its presence. The spiral arms of the Milky Way appear to be fixed, majestic features etched into the galaxy's disk. Yet these arms are not composed of stationary stars. Instead, they represent patterns, density waves that ripple gently through the disk, compressing gas and igniting the birth of new stars as they pass by. Stars drift into these arms, shine brightly for a time, and then glide away. The spiral structure moves at a different pace than the stars, much like a traffic jam weaving through a highway. From a distance, it appears orderly and structured, yet from within, it reveals a dynamic pattern of motion held together by the forces of gravity and time, never stagnant, always in flux. As you explore the Milky Way, you can sense its hum, filled with cosmic radiation. Beyond what your eyes can see, the galaxy radiates with mysterious energies. Cosmic rays, high-energy particles born from supernovae and distant galaxies, stream through the void, passing through you every moment. X-rays and gamma rays shimmer from fading stars and black holes, adding to the intricate tapestry of this celestial environment. Take a moment to reflect on this cosmic dance. What mysteries might still await discovery in the depths of space? Radio waves drift through the cosmos, emanating from gas clouds, pulsars, and the cold breath of hydrogen. These invisible sounds unveil a reality beyond what light can show us. They reveal the violence, magnetism, and ancient fires that still flicker within the galaxy's core. When you gaze up at the night sky, you only catch a glimpse of the Milky Way's true spectrum. Beneath those twinkling stars, the galaxy hums softly, a hidden symphony of colors and frequencies. Above and below the galactic center, there exists a colossal gamma-ray bubble, stretching tens of thousands of light-years. These ghostly structures of high-energy light, known as the Fermi bubbles, glow like twin balloons extending from the heart of the Milky Way. Their origin remains a mystery. They might be remnants of a long-ago outburst from the central black hole, or perhaps they mark a time of intense star formation that once illuminated the core. Regardless, these vast structures drift silently across the galaxy, invisible to our eyes. They serve as poignant reminders that the Milky Way holds a history we cannot fully perceive. They are echoes of violence, wrapped in radiant light, far above the stars we recognize. Our solar system resides in a minor spur, nestled between the grand arms of the Milky Way, a small yet significant part of a vast and complex universe. You find yourself in a unique corner of the universe, known as the Orion Spur. This tranquil stretch of stars lies between the more bustling arms of Sagittarius and Perseus. Here, things are relatively calm. It's not overly dense or particularly active, which might be the very reason life has had a chance to flourish on Earth. In this serene space, supernovae are rare and radiation storms are less frequent. This quiet oasis may have provided the perfect conditions for complexity and life to evolve. From the edges of the galaxy, the Milky Way appears vibrant and dramatic. Yet, within this gentle spur, we have discovered just the right amount of peace for intricate processes to unfold. The Milky Way features a bar-shaped center, and werdwech of the torn to be take for Chopolov the boar. When astronomers observe the galactic core using infrared light, they reveal not a flawless circle, but a thick, elongated bar of stars that stretches across the middle, resembling a luminous bridge. This bar rotates slowly, exerting a gravitational influence that shapes the inner spiral arms of the galaxy. Such bars are common in spiral galaxies. They emerge when stars in the disk begin to drift inward, accumulating along a central axis. Over time, this bar stabilizes, stirring gas, igniting new stars, and funneling material toward the black hole at the core. It represents more than just a structure. It serves as a dynamic engine, sculpting the very heart of the galaxy from within. As you reflect on this cosmic dance, consider the profound interconnectedness of life and the universe. Would you like to explore more about our celestial neighborhood, or perhaps take a moment to rest? You find yourself in a vast cosmic neighborhood known as the local group. The Milky Way, far from being an isolated entity, is part of a collection of over 50 galaxies that drift together through the expanse of space. Among these, the Milky Way and Andromeda stand as the giants, each accompanied by their own families of satellite galaxies. Surrounding them are smaller dwarf galaxies, faint ellipticals, and star-forming galaxies, many composed almost entirely of dark matter. This local group spans more than 10 million light-years, held together not just by their proximity, but by the force of gravity. You are part of this family, quietly spaced yet interconnected by the invisible threads of shared movement and mutual attraction. The galaxies within the local group are gravitationally bound, meaning they are not drifting apart, despite their vast distances. Instead, many are slowly moving toward one another, engaged in a delicate dance, a slow-motion ballet that curves their paths over millions of years. Some of the smallest galaxies orbit the Milky Way like moons, gracefully looping and merging into streams. Others drift independently, yet remain tethered, caught in the intricate web of shared motion. As time unfolds, this group may condense, evolving in ways we can only begin to imagine. Wouldn't it be fascinating to witness this cosmic journey? Galaxies have a dynamic life, merging, fading, and sometimes being absorbed. This is not a static arrangement. It's more like a gentle gathering of cosmic islands, a family drawn closer by the passage of time, inertia, and the vast reach of gravity. When we look at the Milky Way, its disk appears flat from afar, but as we draw closer, we see it as layered. We reside in the thin disk, a wide, vibrant plain filled with young stars, open clusters, and star-forming gas. Above and below us lies the thick disk, older and more diffuse, with stars that are typically older and contain fewer heavy elements. These stars move in orbits that are often tilted and elliptical, hinting at their formation under different conditions, or perhaps stirred by early galactic collisions. The structure of the galaxy's disk is anything but uniform. It is textured and shaped by time, like layers of sediment settling on the ocean floor of the cosmos. Additionally, the Milky Way is woven with a vast, invisible magnetic field that stretches across the disk, rises into the halo, and threads through the interstellar medium. While this magnetic field may seem weak compared to what we experience on Earth, it plays a significant role over vast galactic distances. It influences how cosmic rays travel, guides gas clouds in their collapse, and affects the flow of matter through space. As you contemplate this cosmic tapestry, consider how interconnected everything is, not just in our galaxy, but across the universe. Would you like to continue exploring this wondrous expanse, or perhaps take a moment to rest and reflect? The Milky Way stretches across the night sky, its spiral arms creating arcs and loops that captivate the imagination. To truly understand it, we rely on advanced radio telescopes and meticulous analysis. Yet, its presence is undeniable. The Milky Way does more than just emit light. It pulses with magnetism, a gentle rhythm that flows through its very structure. The interstellar medium, a delicate mixture of gas, dust, and plasma, fills the spaces between the stars. It resembles a fog, mostly invisible to the naked eye. However, when we observe it through radio and infrared telescopes, we uncover a breathtaking complexity. This medium forms intricate filaments, bubbles, shock waves, and dense clouds, all of which serve as nurseries for new stars. Supernovae create vast cavities within this medium, while stellar winds sculpt it into shapes that ripple across light years. The space between stars is not an empty void. Rather, it is a dynamic web of matter and magnetism, the quiet foundation from which galaxies emerge and life ultimately arises. Cosmic rays are constantly streaming through us, originating from the galaxy. Every moment, high-energy particles, primarily protons and atomic nuclei, pass through your body, propelled long ago by the explosive force of dying stars. These cosmic rays are a reminder that we are all connected to the universe in profound ways. As you listen, particles travel close to the speed of light, weaving through magnetic fields, bouncing off clouds, and occasionally colliding with atoms in Earth's atmosphere. In these collisions, they create showers of secondary particles. Most of the time, you don't notice them, yet they carry stories from across the galaxy, evidence of ancient supernovae, traces of distant accelerations, and messages from the violent symphonies of stars. Even as you rest, the galaxy whispers to you through these particles, in silence, in lightless rays. But the galaxy isn't symmetrical. Many diagrams depict it as a tidy, even spiral, yet the Milky Way reveals its imperfections. One side of the disk appears thicker, and some spiral arms are brighter, longer, or more curved than others. The outer disk shows a distinct warp, and even the star counts between hemispheres are slightly uneven. These asymmetries might arise from gravitational encounters, past mergers, or the influence of dark matter. Consider how galaxies, much like living beings, hold traces of their histories in their shapes. They bear scars from collisions, wrinkles of time, and quirks of uneven growth that lend them character and depth. Among these stars, the oldest known one may reside in our halo. High above the galactic plane, astronomers have discovered a star that could be nearly as ancient as the universe itself. Take a moment to reflect on these wonders. The universe is alive with stories waiting to be uncovered. Would you like to continue exploring, or perhaps take a moment to rest? Imagine a star, almost devoid of heavy elements, a remnant from the universe's early days, formed over 13 billion years ago. Long before our Milky Way took shape, this star began its journey, quietly burning with a gentle red glow. It holds stories of the cosmos, serving as a time capsule, a living relic from the dawn of existence. As we explore the galaxy, we notice that its center spins rapidly, much faster than its outer regions. Stars near the core orbit with incredible speed, drawn in by the stronger gravitational pull of a dense mass comprising stars, dust, and the supermassive black hole known as Sagittarius A/Sref. These stars complete their revolutions in just a few million years, while those in the suburbs, like our Sun, take hundreds of millions of years to make their journey. This difference in rotation creates intricate patterns, stretching the spiral arms of the galaxy and preventing it from behaving like a solid structure. The Milky Way moves like a grand wheel, where the rim lags behind its core. The spiral arms, shaped by density waves, are not fixed paths but dynamic streams of stars, constantly evolving. As you reflect on this cosmic dance, consider the stories the universe has to tell. Would you like to continue this exploration, or take a moment to rest? You observe patterns created by waves of higher density moving through the galactic disk. As gas and dust travel through these waves, they become compressed, sparking the birth of stars that illuminate the arms of the galaxy with their youthful brilliance. These stars gradually drift away from the wave, while new ones emerge behind them, crafting a self-sustaining illusion of structure. Much like ripples in a pond or traffic flowing on a highway, the arms are ever-changing, always in motion. From afar they seem still, but up close they reveal a captivating dance of matter and rhythm, sculpted by gravity and time. Stars originate from cold, collapsing gas. In the shadowy arms of the Milky Way, the process of star formation commences in silence. Enormous clouds of molecular hydrogen, sometimes spanning hundreds of light years, drift through the cosmos, chilled to just a few degrees above absolute zero. Within these clouds, gravity begins to assert its influence. Small areas grow denser and start to collapse under their own weight. As the gas descends inward, it heats up, spins, and flattens, forming a protostar at the center. Over time, pressure and temperature escalate until nuclear fusion ignites, heralding the arrival of a new star. From the coldest shadows arise the brightest lights, gently spun into existence by the subtle force of gravity. Star clusters have a fascinating journey, often dissolving into the vastness of the galactic field. Many stars emerge not in solitude, but in groups, forming tight clusters from the same collapsing gas cloud. These clusters, held together by their mutual gravity, drift side by side for millions, even billions of years. However, over time, they start to scatter. Various forces, such as the tidal pull of the Milky Way, close encounters with other stars, and their own internal dynamics gradually pull these clusters apart. Stars drift away, one by one, until the cluster fades into the broader tapestry of the galaxy. Consider this: even our Sun was born in a stellar cluster long ago, alongside its siblings, who now may be scattered, dimmed, or lost in the vastness of distance. Within our galaxy lie the ancient hypermetal poor stars, some of the rarest and most precious objects we can find. These stars possess atmospheres that hold almost no elements heavier than helium. Remarkably, some contain less than 1/10,000th of the iron found in our Sun. They are believed to have formed shortly after the very first supernova, carrying only faint traces of enrichment from a universe that was still in its infancy. These stars are incredibly old and pure, scattered across the halo of the galaxy like distant lanterns illuminating the dawn of time. Each one serves as a relic, a glowing signature from a nearly forgotten epoch. As you reflect on this cosmic journey, consider the stories these stars tell and the mysteries they hold. Would you like to continue exploring this captivating universe, or perhaps take a moment to rest? As you explore the vastness of the Milky Way, you discover that planetary systems are abundant. They are a natural outcome of how stars form. When a new star ignites, it is surrounded by a rotating disk of gas and dust. Within this disk, particles come together, accumulating mass and gradually transforming into planets. Across our galaxy, these systems vary widely. Some are expansive, featuring gas giants and icy moons, while others are more compact, with rocky planets closely orbiting dim stars. Some may even resemble Earth, while others challenge our imagination entirely. The Milky Way is not merely filled with stars. It is a tapestry of solar families, each with its own unique orbits and potential. Earth finds itself near a special region known as the co-rotation radius. In the Milky Way, the spiral arms rotate at different speeds compared to individual stars, creating a dynamic pattern rather than a fixed structure. The co-rotation radius marks a distance from the center where the average speed of stars aligns with the rotation speed of the spiral arms. Our Sun orbits close to this boundary, and this harmonious match in motion may help shield us from the dangers of crossing through the spiral arms, regions with higher star density, frequent supernovae, and gravitational disturbances. As you reflect on these cosmic wonders, consider how they shape our understanding of the universe. Each system tells a story, inviting you to ponder your place within this grand design. Would you like to continue exploring these mysteries, or take a moment to rest? You find yourself in a neighborhood of the galaxy that feels surprisingly stable, not protected by walls, but by resonance. Imagine the Sun bobbing gently as it travels through the galactic plane. As it orbits the Milky Way, it doesn't take a perfectly flat route. Instead, it moves in a graceful wave, rising and falling like a cork in slow motion, drifting above and below the galactic plane over millions of years. This vertical dance is influenced by the gravitational pull of the galaxy's mass, drawing the solar system in and letting it go as it moves. Some researchers have even speculated that this motion may play a role in Earth's extinction cycles, though the evidence remains elusive. Yet, this serves as a reminder, even as the Sun follows its steady course around the center, it isn't just gliding, it's swaying softly through the cosmos. You might wonder about dark matter. While we don't fully understand what it is, we know it exists. Dark matter constitutes most of the Milky Way's mass, yet it remains invisible, not emitting or absorbing light. It passes through ordinary matter as if it were non-existent. However, Its gravitational effects are undeniable. Dark matter binds the galaxy together, explains the unexpected rotation speeds of stars, and influences the formation of vast cosmic structures. As you reflect on these wonders, consider the intricate dance of our universe and the mysteries that still lie ahead. Would you like to explore more, or take a moment to pause? Imagine a universe where the Milky Way holds together through an unseen force. This force, dark matter, isn't something we can see directly. Instead, astronomers observe its presence by noticing how it influences the movement of other celestial bodies. It acts as the galaxy's hidden framework, silent, invisible, yet one of science's most intriguing mysteries. Interestingly, more mass exists outside the luminous disk of our galaxy than within it. While most of the stars we see lie in that bright flat plane, the true majority of the Milky Way's mass is shrouded in darkness. Surrounding the galaxy is an immense dark matter halo that stretches far beyond the furthest stars. This halo is crucial, holding the galaxy together and outweighing the visible stars by a significant margin. Though it contains sparse ancient stars and globular clusters, its main substance remains elusive. When you think of the Milky Way, you likely envision its spiral arms and the star-filled expanse. However, that's just the surface, the radiant exterior, the mass that truly defines the galaxy. Its gravity, its motion, its very essence, lies mostly hidden, wrapping around everything like a gentle shroud. The core of the Milky Way may have once burned brightly as a quasar. Today, it seems quiet, yet evidence suggests it was once a hub of intense activity. Massive gamma-ray structures, such as the Fermi bubbles, and traces of high-energy light in the surrounding clouds, indicate that the supermassive black hole at the center might have flared up as a quasar, a brilliant, volatile beacon fueled by incoming matter. As you ponder this cosmic dance, consider how much remains to be discovered. The mysteries of our galaxy invite us to explore further, revealing the wonders that lie beyond what we can see. Would you like to continue this journey into the unknown? Quasars stand as some of the brightest objects in our universe, shining with a brilliance that can outshine entire galaxies. Imagine if the Milky Way once radiated like this. It would have appeared dramatically different, a spiral enveloped by a dazzling core of light. While that era has faded, its echoes still linger in the cosmos. The structure of galaxies undergoes continuous transformation over billions of years. Although they may seem timeless, galaxies are in a constant state of evolution. Spiral arms shift, bars form and dissolve, and gas flows inward and outward. Stars are born and die, leaving behind a dynamic population that continually changes. Even the shape of the Milky Way's disk, which appears warped, rippling, and lopsided, is gradually altering. Encounters with dwarf galaxies and dark matter can twist or bend the galaxy's structure. Over immense spans of time, the silhouette of the Milky Way shifts, much like a drifting cloud. The galaxy you see today is not the same as it was in the past, nor will it be the same in the future. Its true beauty lies not in permanence, but in its quiet transformation. Gravitational waves ripple through the galaxy, originating from distant cosmic mergers. All across the universe, colossal objects collide. Black holes spiral together, neutron stars crash, and entire galaxies merge. These dramatic events emit gravitational waves, which are ripples in the very fabric of space-time. Though faint, some of these waves traverse the Milky Way, subtly distorting space as they journey through. Take a moment to reflect on this ever-changing cosmic dance and allow the wonder of the universe to inspire you. Detecting them is a challenge, yet observatories like LIGO and Virgo have successfully captured several instances. New experiments are underway to uncover the subtle background hum of gravitational waves that permeates the cosmos. Even as you relax, space itself is in motion. It may not be something you can feel, but it serves as a reminder that far away, the universe is evolving. Consider the stars. They don't all follow neat circular paths around the galactic center. Some take elongated, tilted orbits, tracing long ellipses that rise high above and dip far below the galactic disk. These stars likely have diverse origins, remnants of dwarf galaxies consumed by the Milky Way, or survivors of ancient cosmic upheavals. Their orbits act as clues, revealing a three-dimensional map of the galaxy's turbulent history. By observing their movements, astronomers piece together the invisible structure of the Milky Way's mass and memory. These stars drift like messengers from disrupted systems, tilted and stretched, yet still part of a greater whole. The Milky Way continuously emits neutrinos, nearly impossible for us to detect. Trillions of these ghostly particles pass through your body every second, originating from various cosmic events. They are born in nuclear reactions from the sun, from supernova explosions, and from cosmic rays colliding with atoms in space. Isn't it fascinating to think about how connected we are to the universe? As you ponder this, allow yourself to feel the wonder of these cosmic dynamics. Imagine the Milky Way, illuminated by countless particles that are nearly weightless and unreactive, gliding through the cosmos without leaving a trace. Special observatories, hidden deep underground or beneath layers of ice, strive to capture these elusive particles, hoping for a glimpse of the light that emerges from a rare collision. Neutrinos, these ghostly messengers, carry vital information from realms beyond our sight, places like the cores of stars, collapsing giants, and the unseen energy that permeates the galaxy. They are the faint whispers of cosmic fire. As you delve deeper, you realize that interstellar space isn't as empty as it seems. It's a turbulent ocean where the space between stars is anything but smooth and still. The interstellar medium, composed of thin clouds of gas and dust, is constantly agitated by shock waves, magnetic fields, and the movement of stars. Here, temperatures can fluctuate dramatically. Streams of material collide and blend, creating a dynamic environment where clouds stretch, fold, and tumble in a dance of chaos. On a grand scale, this turbulence resembles a slow-motion ocean swirling through the galactic disk. It influences everything from star formation to cosmic rays and even the evolution of galaxies. What appears as calm starlight from a distance reveals a vibrant, rippling fabric up close, shaped by invisible winds and ancient energy. And within the galactic halo, there may be rogue planets, celestial bodies that wander through space, unbound by any star. Some of these planets form within a system, but are ejected, drifting into the vastness of the universe. Take a moment to ponder this intricate dance of the cosmos, where every element plays a role in the grand story of the universe. Would you like to explore more about these cosmic wonders, or perhaps take a moment to reflect? Imagine a universe where some worlds have never known the warmth of a star. These are rogue planets, drifting through the vastness of space, cold and solitary. Though they elude our detection, studies indicate there could be billions of them scattered throughout the Milky Way, even in the distant outer regions where stars are scarce. Without light or warmth, they float in silence, warmed only by their own internal heat. These planets are the orphans of the galaxy, wandering aimlessly along lonely paths in the darkness between stars. As we explore this cosmic landscape, we find that magnetic fields play a crucial role in shaping the flow of cosmic dust. This interstellar dust, composed of tiny grains of carbon and silicon, moves not just under the pull of gravity, but is also guided by the galaxy's magnetic field. These invisible currents weave through the Milky Way, directing the motion of charged particles and influencing how gas and dust align. In certain regions, dust grains spin rapidly, emitting faint microwave light. In others, they align with magnetic lines, polarizing the starlight that filters through them. By understanding these intricate effects, astronomers can map out the structure of the magnetic field and even account for its influence in cosmic background studies. Dust is far from passive. It dances to a magnetic rhythm, revealing hidden patterns in the depths of the dark. As you reflect on this cosmic ballet, consider the mysteries that lie beyond our view. The universe is filled with wonders waiting to be discovered. Would you like to delve deeper into this fascinating realm, or perhaps take a moment to ponder its beauty? Imagine the cosmos, where some stars are transformed through the dramatic collisions of neutron stars. When two of these dense stellar remnants spiral together and collide, they unleash one of the universe's most spectacular events, a kilonova. In this brief, blinding explosion, vast amounts of heavy elements are born. Gold, platinum, uranium, and more are forged in the heart of this chaos, cast into the vastness of space, mingling with gas, and eventually contributing to the formation of new stars. As you gaze up at the night sky, consider that some stars in the Milky Way carry the unique chemical signatures of these extraordinary events. They are enriched with elements that can only originate from such cosmic collisions. These stars are not merely points of light. They serve as record keepers of ancient cataclysms, glowing with the remnants of stellar destruction and cosmic transformation. Now, let's delve deeper into the Milky Way. At its heart lies a bar of stars, an elongated ribbon of light that crosses the central bulge. But intriguingly, astronomers have discovered signs of another smaller bar hidden within this structure, tilted at a different angle and rotating independently. This inner bar is challenging to observe directly, shrouded by dust and distance. Yet, its gravitational influence is evident in the movements of nearby stars and gas. These bars may play a crucial role in channeling material toward the supermassive black hole at the galaxy's core, nourishing it and shaping the dynamics of this stellar hub. Isn't it fascinating how the universe tells its story through the very stars you see? Take a moment to reflect on this cosmic dance, and when you're ready, let's continue exploring the wonders of the universe together. The center of the Milky Way is not just a simple shape. Instead, it resembles a complex, shifting labyrinth filled with light and motion. Gas flows into the galaxy from the cosmic web, creating a dynamic system. The Milky Way is not isolated. It actively draws in fresh gas from the intergalactic medium. Long, delicate streams of gas traverse this vast cosmic network, providing the essential materials for new stars and replenishing what the galaxy loses over time. Some of this gas arrives as cold filaments, gently slipping into the galactic disk, while other streams come in hotter, igniting in spectacular displays of ultraviolet or X-ray light. These invisible rivers play a crucial role in sustaining the galaxy's growth and evolution, connecting it to the broader universe that surrounds it. Even now, the Milky Way continues to draw from distant reservoirs, nourished by threads of matter that were spun from the very beginnings of the cosmos. As massive stars reach the end of their life cycles and explode in supernovae, they create enormous cavities within the interstellar medium. These cavities can merge into vast bubbles of hot gas that rise through the galactic disk, venting into the halo above. This process results in a kind of chimney, a channel through which energy, gas, and magnetic fields escape from the galaxy's plane. These chimneys play an essential role in regulating the pressure of the interstellar medium, redistributing metals, and shaping the structure of the halo. Take a moment to reflect on this intricate dance of cosmic elements. Isn't it fascinating how the Milky Way continuously evolves, drawing strength from the universe around it? As you ponder this, consider the vastness of the cosmos and how it influences our very existence. Feel free to continue exploring this captivating journey, or take a moment to rest and absorb it all. The galaxy breathes, not just within its spiral arms, but through towering columns that send its energy into the vast darkness. It glimmers in X-rays, a light emitted by ancient stars and black holes. While the Milky Way seems serene in visible light, it reveals a fierce glow in other wavelengths. X-rays surge from its core, from collapsed stars, and from the edges of black holes. In binary systems, white dwarfs and neutron stars can draw in matter from their companions, heating it to millions of degrees. Even the hot gas in its halo emits faint X-rays, uncovering the galaxy's grand structure. You cannot perceive this high-energy light with your eyes. However, telescopes like Chandra and XMM Newton offer a strikingly different view of the galaxy. It is not merely a tranquil spiral. It is a realm of extreme temperatures, dense remnants, and hidden radiation. Pulsars serve as cosmic clocks scattered throughout the Milky Way. When a massive star perishes and collapses into a neutron star, it may spin rapidly and precisely, with beams of radiation sweeping across space. These pulsars can rotate hundreds of times each second, pulsing in regular measurable rhythms. They are so reliable that astronomers utilize them as cosmic timekeepers, tracking their signals to measure distances, test gravity, and even search for gravitational waves. As you reflect on this, consider how the universe reveals its secrets in ways that often go unnoticed. Would you like to continue exploring this cosmic wonder, or perhaps take a moment to rest? As you gaze across the vast expanse of the Milky Way, you notice the pulsars blinking quietly. These remnants of stellar death serve as remarkable beacons of order, keeping time not just for minutes or days, but for entire epochs. They tick steadily in the silence that exists between stars, while radio waves unveil the hidden structure of our galaxy. Much of the Milky Way remains elusive in visible light, shrouded by dust, distance, or faintness. Yet, radio waves have the unique ability to penetrate these barriers, revealing structures that would otherwise remain unseen. They trace the cold hydrogen gas, outline magnetic fields, and highlight emissions from pulsars, supernova remnants, and even distant quasars that lie beyond our galaxy. With the help of arrays of radio telescopes, astronomers have meticulously mapped the spiral arms of the Milky Way, measured the warp of its disk, and discovered regions where stars are forming, cloaked in darkness. In these areas where light cannot reach, radio soundings allow us to see what is hidden. The galaxy communicates in a language that we cannot hear, yet science has learned to translate these signals into shapes and shadows. It's fascinating to consider that our sun likely originated in a stellar cluster. Stars rarely form alone. They typically emerge in groups, stellar clusters that arise from the same collapsing clouds of gas and dust. Our sun was almost certainly one of these stars, once sharing space with hundreds, perhaps even thousands of sibling stars, all born from the same cosmic cradle. Isn't it awe-inspiring to think about the intricate connections that bind the stars together? As you reflect on this cosmic tapestry, you might feel a sense of wonder about your own place in the universe. You are part of this grand narrative, woven through time and space, Imagine a vast expanse where gravitational tides, wandering stars, and the motions of galaxies gently scatter a cluster of stars. Over time, the sun's siblings have drifted far, each one flung into its own orbit, carrying echoes of a shared past. Some might still shine close by, hidden among the countless stars, a lost family adrift in a sea of light. The sun's siblings are now scattered throughout our galaxy. Even though the cluster where the sun was born has long since dissolved, astronomers are on a quest to find these lost relatives. They seek stars that share the same age, motion, and unique chemical signatures as our sun. With the help of extensive surveys like Gaia and detailed spectroscopic databases, researchers hope to uncover these long-lost kin. A few promising candidates have already emerged, stars that may have originated from the same cloud of enriched gas. If they are found, these stars could offer invaluable insights into the conditions that shaped the sun and the early solar system. You see, our place in the galaxy isn't entirely solitary. Somewhere out there, the sun's ancient kin may still be shining. As the Milky Way spins, its galactic disk wobbles gently, like a plate that has been nudged off balance. This subtle warp is most apparent in the outer regions, where the disk bends upward on one side and downward on the other. Isn't it fascinating to think about the connections that might still exist among the stars? As we continue this journey of discovery, you might find comfort in knowing that the universe holds more stories than we can imagine. Would you like to explore more about our cosmic family? Have you ever considered the hidden dynamics of our Milky Way galaxy? It might be influenced by the gravitational pull of nearby dwarf galaxies, interactions with dark matter, or even internal asymmetries. Imagine a slow, gentle wobble, like a vast wave moving through the stars. From where you stand on Earth, you may not feel it, but from a distance, the Milky Way reveals itself as a living, breathing entity, an undulating sheet of stars that curves gracefully as it turns. Galactic tides play a crucial role in shaping our cosmic neighborhood. Just as the moon's gravity pulls at the tides on Earth, the immense mass of the Milky Way exerts tidal forces on everything it contains. Star clusters, satellite galaxies, and globular groups all feel this uneven gravitational pull. Over time, these tides can stretch and distort them, pulling out long stellar streams or gently peeling stars away from their orbits. Many of the faint arcs of stars you see mapped across the night sky are remnants of such encounters. Entire clusters are in the process of being unraveled, with galaxies slowly torn apart. This unraveling does not happen suddenly, rather it occurs patiently, strand by strand, over millions of years. You might wonder about the Milky Way's mass. It's surprising, but measuring it proves to be remarkably challenging. Stars and gas represent only a small fraction of the total mass. So, as we explore the cosmos, we continue to uncover the mysteries woven into the fabric of our galaxy. Would you like to delve deeper into these cosmic wonders? You find yourself contemplating the vastness of the universe, particularly the enigmatic dark matter halo surrounding our Milky Way. This invisible mass eludes direct observation, yet estimates suggest it could possess a mass nearly 1 trillion times that of our Sun. Some even propose it could be even greater. The challenge lies in measuring the speed at which stars orbit at great distances, a task complicated by limited data and the unseen forces at play. Our galaxy, the Milky Way, is familiar yet shrouded in mystery. It might be heavier than Andromeda, a galaxy that has long been considered more massive due to its larger size and brightness. However, recent findings indicate that the Milky Way's dark matter halo could be broader and denser than we once thought. If true, this means our galaxy might actually outweigh Andromeda, despite its seemingly modest appearance. Why does this matter? The answer lies in the future. When these two galaxies eventually merge, their respective masses will dictate the dynamics of that cosmic encounter. The Milky Way, with its serene spiral arms, may harbor more weight than we ever realized. You might also consider the Magellanic Clouds, those bright satellite galaxies visible from the southern hemisphere. They are believed to be on their first orbit around the Milky Way, adding another layer to the intricate dance of our galaxy and its companions. As you reflect on these cosmic relationships, you are reminded of the wonder and complexity of the universe that surrounds us. New evidence suggests that these celestial bodies may be newcomers, recently captured in the vastness of space. Their speed and trajectory indicate that this could be their first close encounter with our galaxy. If this is the case, they aren't longtime companions, but rather distant wanderers, just now feeling the gravitational pull of the Milky Way. Their arrival has stirred the outer disk, warping the galaxy's shape, as if the Milky Way is responding to this new gravitational presence. In this quiet expanse of the sky, we sense the thrill of first encounters. The Mellon Stream appears as a ribbon of stripped gas, trailing behind it a vast expanse of hydrogen. This structure, known as the Mellon Stream, stretches over hundreds of thousands of light years, curving and arching across the southern sky. It was pulled away by tidal forces as dwarf galaxies passed close to one another and to the Milky Way. This stream, visible only in radio wavelengths, whispers tales of motion and loss, an invisible thread connecting us to the cosmos. In the future, this stream may nourish new star formation within the Milky Way, or settle into the halo, becoming a thread of memory that links our galaxy with others. Some gas clouds orbit in polar directions, reminding us that not everything within the Milky Way adheres to the tidy plane of the disk. As you reflect on this cosmic dance, consider the stories that lie beyond our sight, waiting to be discovered. Imagine a scene where clouds of gas and distant stars weave in intricate inclined orbits, gliding above and below the Milky Way's main structure. These polar orbits are likely remnants of ancient mergers, when dwarf galaxies or wandering clouds were drawn in at unusual angles. Over the ages, they continue to trace their tilted paths, much like comets orbiting a planet. These misaligned orbits serve as records of cosmic disruption, reminding us that the galaxy is not a static entity, but a living structure shaped by the unpredictable currents of cosmic history. Surrounding the remnants of past starbursts, enormous shells of gas can be found in various regions of the Milky Way. Some of these shells stretch across hundreds of light years, standing as testament to powerful episodes when clusters of massive stars were born, lived out their brief existences, and then exploded in rapid succession. The winds generated by these supernovae carved vast cavities in the interstellar medium, sending gas cascading outward in all directions. Although the expansion of these shells may slow over time, their presence lingers. They are like ghostly bubbles, marking the locations where the galaxy once blazed with the fervor of stellar birth and death. These shells are the fossils of cosmic fireworks, still resonating in the cold expanse of space. In the denser regions of the galaxy, stars occasionally collide, adding another layer to this dynamic cosmic dance. Space stretches infinitely, while stars appear diminutive in comparison. Yet, within the Milky Way's densest areas, especially at the cores of globular clusters, stars can come close enough to interact and sometimes collide. When this occurs, the spectacle is nothing short of breathtaking. You might witness a brilliant burst of light, the union of two suns, or the birth of a rare blue straggler star, one that seems younger than its companions. These stellar collisions are uncommon, but they certainly happen. Over billions of years, the gravitational dance and chance encounters within tightly packed stellar neighborhoods can lead to remarkable transformations. In these bustling cosmic cities, time behaves differently, and the vastness of space is never truly empty. Binary stars, often found in pairs orbiting one another, can be torn apart by tidal forces. While these stars share a gravitational bond, even that connection can be disrupted. If a binary system ventures near the Milky Way's central black hole or passes through a dense cluster of stars, tidal forces may alter their paths. One star may be flung away, while the other is captured or slowed down. In some instances, a companion may even be ejected from the galaxy entirely, becoming a rogue star, racing through the vastness of intergalactic space. These silent breakups occur in regions seldom observed, where ancient partnerships are quietly unraveled by the relentless pull of gravity. As you contemplate this cosmic ballet, consider how interconnected and fragile these stellar relationships truly are. Wouldn't it be fascinating to explore more about our universe and its hidden wonders? Imagine a universe where some stars break free from their galactic home. While most stars remain bound to the Milky Way, a few manage to reach an incredible escape velocity of over 500 kilometers per second. These exceptional stars are known as hypervelocity stars, and they are both rare and fascinating. Some of them are believed to be ejected due to interactions with the supermassive black hole at the heart of our galaxy. Others may be propelled outward through complex encounters or explosive events in binary star systems. Once they escape, these stars embark on solitary journeys through intergalactic space, like tiny lighthouses drifting far beyond the spiral arms of the Milky Way. They carry with them the memories of their home galaxy, becoming solitary pilgrims navigating the vast darkness between galaxies. Interestingly, the Milky Way is not just a cradle for stars born within its own boundaries. Some stars may have originated in other galaxies, captured during cosmic mergers, or flung into our halo from distant regions of the local group. These intergalactic wanderers often follow unusual orbits, tracing paths far from the galactic disk and moving through the outskirts or halo of the Milky Way. You can identify them by their distinctive composition or motion. These stars stand out, not quite fitting into the local patterns. Like cosmic immigrants, they bring with them stories from other environments, histories, and skies, enriching the tapestry of our universe. As you reflect on this cosmic journey, consider the incredible tales these stars might tell, connecting us to the broader universe beyond our own. Would you like to explore more about these celestial travelers, or perhaps take a moment to ponder their silent stories? The Milky Way is not a closed system. It is a vibrant mosaic, gradually woven together by the passage of time and the movement of celestial bodies. Imagine a fountain of gas cycling between the disk and halo of our galaxy. This gas rises and falls in a gentle loop, a process we call the galactic fountain. Supernovae and stellar winds heat and propel material upward into the halo, where it cools, condenses, and eventually rains back down over millions of years. This ongoing cycle stirs the interstellar medium, redistributes heavy elements, and plays a crucial role in regulating star formation. It resembles a quiet breath, a rhythmic exchange of matter between the dense plane and the vast halo. In this way, the galaxy does more than just spin. It circulates, it inhales and exhales, maintaining its structure over unimaginable spans of time. Within the galaxy's dust grains lie organic compounds, Scientists have discovered complex organic molecules drifting in the clouds of interstellar dust that float between stars. These carbon-based compounds serve as the essential building blocks for life. They include polycyclic aromatic hydrocarbons, simple sugars, and alcohols, among others. While these compounds are not alive, they are chemically rich, formed in the atmospheres of dying stars, or within cold clouds shaped by radiation. As we reflect on this magnificent process, consider the intricate dance of elements and compounds that may one day contribute to life. Isn't it fascinating to think about the possibilities? Imagine tiny grains carried across light years by galactic winds, settling into the gas that eventually forms stars and planets. Some of these grains might have even landed on early Earth. This cosmic dust is not merely debris, it serves as a cargo of potential, drifting silently through the vastness of space. Interstellar clouds could be the seeds of solar systems, providing essential ingredients for life. The birthplaces of stars are also where new worlds begin to take shape. As planetary systems emerge from collapsing clouds of gas and dust, they inherit the unique chemical signatures of their parent nebula. If that nebula contains water, carbon compounds, and other fundamental building blocks of biology, those essential ingredients may find their way into comets, asteroids, or even planets. Certain regions of the Milky Way are particularly rich in prebiotic chemistry, suggesting that the conditions for life might arise naturally. The seeds of life may be scattered throughout the galaxy, tucked away in its coldest corners, patiently waiting for the right environment to flourish. Consider the stars themselves. Some rotate hundreds of times faster than our sun. While most stars spin, a select few spin with incredible speed, completing a full rotation in just a few hours. These rapid rotators are often young, massive, and unstable, with equators that bulge due to centrifugal force. As you reflect on this cosmic dance, what thoughts come to mind? The universe is full of mysteries, and each grain of dust carries a story waiting to unfold. Would you like to continue exploring, or perhaps take a moment to rest? Some stars reach astonishing speeds, flinging off material and creating glowing disks around themselves. The sun, for instance, completes a rotation every 25 to 35 days, depending on its latitude. Yet these rapidly spinning stars can rotate hundreds of times faster, nearing their physical limits. Their internal structures and evolutionary paths are distinct, and although their lifespans may be brief, they spin like sirens in the dark. The galaxy is tilted in relation to the ecliptic. When you gaze up from Earth, the Milky Way stretches across the night sky, forming a graceful band of light. However, it does not align with the plane of our solar system. The galactic plane, the flat disk where most of the galaxy's stars reside, is tilted by about 60 degrees compared to the ecliptic, which is the path traced by the sun and the planets. This tilt explains why the Milky Way rises at an angle and shifts its position with the changing seasons. You are part of this vast galaxy, yet your own little solar system is slightly skewed, a small tilted boat adrift in a larger spinning sea of stars. Some stellar remnants even predate the galaxy's disk. Astronomers have discovered white dwarfs among the faint stars in the halo. These are the cooling cores of once luminous stars, older than the thin disk of the Milky Way itself. And as you reflect on these celestial wonders, consider how they connect to your own journey through the universe. Would you like to continue exploring, or perhaps take a moment to rest? Imagine gazing into the vastness of the cosmos, where ancient remnants whisper stories of a time when our galaxy was still in its infancy. These remnants formed in the early days of the Milky Way, offer a glimpse into a deeper history etched in the outer halo. For billions of years, they have burned brightly, slowly fading, yet carrying the echoes of an era when the Milky Way was still finding its form. While the disk of our galaxy shines with vibrant stars, the halo holds memories that stretch even further back. The most distant stars orbit well beyond the familiar spiral arms, journeying tens or even hundreds of thousands of light years from the galactic center. They traverse the galactic halo on slow, sweeping paths, taking billions of years to complete a single orbit. Many of these stars were likely captured from smaller galaxies during ancient mergers, now drifting at the fringes like distant sentinels. Though faint and sparse, these stars play a crucial role in defining the size, shape, and gravitational influence of the Milky Way. The galaxy is not merely what meets the eye. It extends deep into the shadows, shaped by these wanderers at its edge. Interestingly, the shape of the Milky Way is not perfectly symmetrical. While we often envision it as a harmonious spiral, it carries subtle lopsidedness, revealing the complex nature of its formation and evolution. As you ponder this intricate tapestry of stars and history, consider what mysteries still lie beyond our view. The universe is vast, and the stories it holds are waiting to be discovered. Would you like to explore more, or take a moment to reflect on this cosmic journey? Imagine a galaxy that is not perfectly symmetrical. One side of its disk is thicker than the other, and the spiral arms vary in brightness and length. Even the stellar halo sits slightly off-center. These irregularities likely stem from gravitational interactions with dark matter clumps or past mergers with other celestial bodies. The galaxy resembles a spinning dancer, its skirt caught in the wind, creating a captivating dance of tugs and twists. This beauty lies in its imperfections, a graceful balance shaped by the passage of time. Astronomers utilize variable stars to map the galaxy. These stars pulse in brightness at regular intervals, expanding and contracting like gentle heartbeats. Certain types, such as Cepheids, have well-established relationships between their brightness and pulse periods. By observing how long it takes for a star to brighten and dim, astronomers can ascertain its true luminosity. By comparing this with its apparent brightness, they can determine its distance from us. These variable stars act as cosmic yardsticks, illuminating our understanding of the Milky Way's shape, structure, and scale. They serve as guiding lights, measuring the dark expanse scattered throughout the spiral. The Gaia mission is transforming our comprehension of the Milky Way, unlocking secrets that were once beyond our reach. As we explore this vast galaxy, we invite you to join us in this journey of discovery, where every star tells a story. You are about to embark on a journey through the cosmos, guided by the remarkable Gaia spacecraft, launched by the European Space Agency. This incredible mission is crafting the most detailed map of the Milky Way ever created. By meticulously measuring the positions, motions, and brightness of over 2 billion stars, Gaia unveils the galaxy's three-dimensional structure and its movement through time. As each new data release emerges, Gaia enhances our understanding, transforming what once appeared as a hazy smear of stars into a vivid, dynamic map. This endeavor represents astronomy's most ambitious star chart, a quiet revolution happening among the stars. Imagine looking up on a dark night, far from the city lights. You might catch a glimpse of a hazy river of starlight stretching across the sky. This is the galactic plane, the thickest slice of the Milky Way's disk. It isn't just a line, it's a profound depth, a vast band where most of the galaxy's stars reside. Within this plane, stars are densely clustered, dust layers are abundant, and the formation of new stars is a common sight. From our unique perspective, we gaze along the grain of the galaxy, exploring its richest corridors. This band is not only captivating, it serves as the bustling heart where stars are born and where they ultimately meet their end. So, as you reflect on this cosmic tapestry, allow yourself to wonder about the mysteries that lie beyond. Would you like to continue exploring this celestial marvel? Or perhaps take a moment to rest and absorb the beauty of the universe? The night sky reveals its brightest secrets toward the galactic center. As you look in the direction of the constellation Sagittarius, you find a stunning concentration of stars, dust, and unseen mass that defines the core of the Milky Way. Unfortunately, from your vantage point on Earth, the very heart of our galaxy remains hidden from view, shrouded by dust clouds. However, this area shines brilliantly in infrared and radio wavelengths. Even with just your eyes, you notice that this region appears more crowded and luminous, filled with the overlapping light of billions of stars. You and I orbit far from this dazzling center, nestled in the quiet suburbs of the galactic disk. But when you gaze inward, you catch a glimpse of the bustling city at the galaxy's heart. From our unique perspective, we observe the Milky Way stretching across the sky. Living within it, we cannot simply look down upon the Milky Way from above. Instead, we see it as a flat ribbon of stars, bending only at the horizon. This viewpoint compresses the galaxy into a single arc, making it challenging to fully comprehend its grand structure. It has taken centuries of observation, cataloging, and mathematical reasoning for us to understand the spiral shape we inhabit. As you stand on Earth, gazing through the disk of the galaxy is akin to standing in a forest and looking along the line of trees. You may not see the shape you are part of, but you can certainly feel the vastness that surrounds you. The galaxy contains far more than you could ever hope to see. Even with our most advanced instruments, you can only catch a glimpse of a small part of what the Milky Way holds. Dust obscures the light, and motion often fades into silence. Dark matter vastly outnumbers the stars that shine. Between each star lies a void, yet within that emptiness lies incredible potential. It is what you suspect, what you infer, and what you yearn to understand. This vastness cradles ancient light, future stars, wandering worlds, and questions that remain unanswered. In this immense expanse, you find yourself a single planet among many, orbiting a quiet star, adrift in a narrative too grand for the eye to fully comprehend. As you dive deeper into thought, the stars start to fade behind your reflections. You've journeyed through countless subtle truths, from the warp of the galaxy's disk to the most distant halo stars. You've witnessed the birth of new suns and the remnants of those long gone. You've navigated through dust and gas, light and shadow, and everything that lies in between. You are woven into the fabric of this galaxy. You are not merely a visitor on Earth, you are an active participant in its unfolding story. The iron coursing through your veins was forged in the hearts of stars, and the oxygen filling your lungs was crafted in ancient cosmic explosions. Embrace your connection to this vast universe. The atoms that make up your body have a remarkable history, tracing back to the very beginnings of the universe. They originated from the same matter that fuels the stars and dances through the clouds of interstellar dust. As you settle down tonight, the galaxy is alive with activity. Stars are being born, light is journeying across vast distances, and silent orbits are continuing their timeless dance. You find yourself floating in this cosmic expanse, a small warmth in the dark, nestled within the spiral arms of a serene, luminous ocean. If you're still awake, feel free to embrace the next chapter of your journey now. I wish you a peaceful night filled with gentle dreams. Good night. Imagine yourself in a serene space filled with gentle sounds that invite you to pause and reflect. The atmosphere is calm, allowing you to breathe deeply and let go of any tension. As you settle in, consider the beauty of the present moment. What thoughts come to your mind? Perhaps you notice the soft light filtering through the windows, casting delicate shadows that dance across the room. This is your time. Embrace the stillness and allow yourself to explore the sensations around you. Feel the warmth of the sun on your skin, the gentle rustle of leaves outside, or the comforting rhythm of your breath. Every moment holds a story, a chance to discover something new about yourself. What insights might emerge if you take a moment to listen? As you reflect, remember that it's okay to let your thoughts wander. Embrace the curiosity that arises. You might find that the answers you seek are already within you, waiting to be uncovered. Take a deep breath, and when you're ready, invite yourself to continue this journey, or simply rest in the tranquility of this moment. Your experience is uniquely yours, and it's a privilege to share this space with you.